Okay, I need to go through division of polynomials right quick. And this is just like regular old-fashioned dividing. So if I divided 2 into 562, and I would say, first of all, 2 goes into 5 twice. 2 times 2 is 4. Subtract. Bring down the 6. 2 goes into 16, 8. And then 2 goes into 2, 1. So regular old dividing. I can do that with polynomials as well. It's a little bit more involved. The quickest way to divide polynomials, the same process here is if I took now and multiplied 2 times 281, I should actually get back to 562. Because division and multiplication undo each other. So if I just divided, I can go back by multiplying and get back where I started from. So with that basic mindset in mind, that if I'm going to take it and divide by a number and get a factor, that if I multiply those two factors, I should get back where I started from. So we're going to start with a very simple polynomial. So if I took x squared plus 5x plus 6, and I ask you to divide it by x plus 3, then there's a way to do it using long division, but the most practical way that we're going to use on down through the rest of what we're doing in this chapter, which is solving polynomials, is we're going to do a thing called synthetic division. And what, in order to do synthetic division, you're going to do is you're going to take and set x plus 3 equal to 0, what you're dividing by, and you're going to get x by itself. So in order to do that, we would subtract 3 on both sides, so x is equal to negative 3. So negative 3 is going to go out here by itself. All you're going to do now is bring down the coefficients, the numbers in front of the terms of each of these. So 1x squared, 5 in front of x, and a positive 6. I know this seems crazy, but bring down the 1. Negative 3 times 1. So multiply these two and shift your answer and put it over here. So negative 3 times 1 is a negative 3. Now you're going to add those two numbers. A 5 and a negative 3 added together is positive 2. Multiply again. Negative 3 times 2 is negative 6, but shift your answer and put it over here. A 6 and a negative 6 is 0. This last term is always your remainder. Sometimes you'll have a remainder, and sometimes you won't. In this case, I have no remainder, which means it divided into it evenly, so it's a factor, because any number that divides into it evenly with no remainder is a factor. And I hope you can hear me. Okay, just making sure that you can hear me. Hopefully it's working. So now what we're going to do is take, and what we divided by was the negative 3, but that was the same thing as x plus 3, so that factor was x plus 3. So now if I take what I divided by and the answer that I got, now this is my answer, but in order to put it back in polynomial form, these are going to be the coefficients, and so it's going to be a 1x. Whatever you started with, your answer is going to start with 1 less degree than that. So if this started with x to the second, this is going to start with x to the first, and then we're just going to keep on going down by 1 power of x. So now there's no x's on this one, because 1 less power of x would just be x to the nothing. And so then my answer should get me right back to where I started. So this divisor times the answer should equal what I started with. Well, I can check that. X times x is x squared plus 2x plus 3x plus 6, which is in fact x squared plus 5x plus 6. So this is just simply dividing. I just undid that. All right, let's do another one like that. So if I take x to the second plus 4x plus 3, and I ask you to divide it by x plus 1. Whatever I'm dividing by, I'm going to set equal to 0 and move it. And so x is going to equal to negative 1. So negative 1 is going up here in the box. The coefficients of these come down, so 1, 4, and 3. Always bring this first number down to the very bottom row. Whatever that first number is. Sometimes it's a 1, sometimes it's a 10, whatever, but bring it all the way down. And then we start multiplying. Negative 1 times 1. The answer goes over here. And then add, which gives me 3. Multiply. Negative 1 times 3 is negative 3. And then add. So again, I have no remainder again. This time I have no remainder. So my divisor was x plus 1. So if that multiplied times the answer which is 1x, 1 less power than x squared is x to the first, plus 3 with no x, then this is my answer. So this goes into it x plus 3 times. Now, they're not always that short, so if I give you one like this one, 27 x to the third. Oh no, that's not a good one. Hang on. No. Alright, so if I do this one, 21, 2x to the third plus 9x to the second plus 5x minus 9, and I divide that by x plus 3. So, set x plus 3 equal to 0. Subtract 3 on both sides. X is equal to negative 3. So I'm going to take a negative 3 up here. All the coefficients are coming down. So 2, 9, 5, and negative 9. First number comes down, whatever that first number is. Multiply. So negative 3 times 2 is negative 6. It's shifted over. And then add, which is 9 and a negative 6 is 3. Start over again. Multiply and shift. Negative 3 times 3 is a negative 9. And add, it's negative 4. Multiply. Negative 3 times negative 4 is positive 12. And add, is that positive 3? So you'll notice this time I have a remainder. And that's okay. So if we go back and remember, like in 3rd grade when you divided, and you divided 2 into 15, and you got 7 and 14 with 1 left over, then this was your answer, and then you just put your remainder over your divisor. So we're going to do the same thing here. So this is going to be x plus 3 times 2 and x. This one started with x cubed, so this answer is going to start with 1 less power of that, which is x squared, plus 3, and then keep descending by 1 more power of x. So if I had 2, I'm going to go down again to x to the first, minus 4 with no x's, and the remainder is simply going to be plus 3 over whatever my divisor was, which was x plus 3. Now, for the most part, we're not going to deal with many that have remainders. Now, the ones I'm going to assign you have some remainders, but just to practice the process of dividing, as we go on in and start solving polynomial functions, we won't be messing with any that have remainders. We'll only be interested in ones that have a remainder of 0, because we're only going to be interested in ones that have factors. And factors are numbers that divide in evenly with no remainders. So for the time being, just for the sake of you practicing the synthetic division business, some of them have remainders, but not all of them will. So let's see if I can give you one more that is a good example. All right, so if we take 3x to the third plus 8x squared plus x minus 7, and we divide by x plus 2. So x plus 2 set equal to 0 is going to be x equals negative 2. So we're going to put a negative 2 out front. 3, 8, 1, and negative 7. Bring down the 3. Multiply. And then add. Multiply. And then add. Multiply. And then add. So again, we have a remainder of 1. So my answer is simply going to be what I divided by, which is x plus 2, times my answer, which is 3x, started with x cubed, so this one begins with x squared, 1 less down, plus a 2, 1 less down, power of x, and then minus 3, no x. This time I would say minus my remainder because it's a negative, so minus 1 over what I divided by. And that's as far as you need to go with that. So you have a couple of these on the test as well. I believe they actually turn out to be a remainder of 0, but I'm not positive. But that's it for dividing polynomials. The next thing that we need to talk about that we've done this week is actually starting to figure out how many types of solutions we could have to a polynomial, because keeping in mind that a polynomial function is just like a quadratic, like we did before when we said, oh, here's the 2 solutions where it crosses the x-axis. Well, if I have a function that does this, it still has solutions. It now just has more solutions than we did in the past. And so what we're going to try to do is start finding all of those solutions algebraically. It gets a little complicated, so I'll start another video on how to do that as well, and hopefully this will help alleviate that, and then I'll send you some assignments that you can work on to practice this as we go.